Hello everyone, welcome back. My name is Mr. Koval, and in this video we're going to talk about buffers. So let's get into this. So buffers are solutions that are going to resist the pH change. So normally if you just have a weak acid or a weak base in solution, if you dump in some acid or some base, it's not going to overcome that pH change. There'll be a great pH change in the solution. The thing about buffers is that if you add in an acid or a base, it's going to neutralize that acid or base and keep the pH relatively the same. It'll increase just a little bit or decrease a little bit, but it's not going to be a huge change in the pH. And that's one of the characteristics of buffers. That's actually the characteristic of a buffer. So buffers are going to resist pH change by neutralizing the acid. So they're going to neutralize added acid or added base. So how does a buffer do that? How does it neutralize either an acid or base? And that's because buffers are going to contain either one of these two combinations. Either it's going to have significant amounts of a weak acid along with its conjugate base, right? Or it'll have significant amounts of a weak base and its conjugate acid. So those are the key ingredients of a buffer. So weak acid with its conjugate base or weak base with its conjugate acid. And it's got to be significant amounts of. It can't be a little bit of one and a whole bunch of the other. So you got to have a good mixture of each one, and you've got to have a large amount of each one. So the weak acid or its conjugate base, or the weak base and its conjugate acid. So here's an example, or a couple of examples. So one example is our blood. So our blood contains a buffer. So here you have H2CO3, that's carbonic acid, and then we have the bicarbonate or the bicarbonate ion here. So when we breathe in oxygen and we have carbon dioxide come out, that carbon dioxide is coming from the buffer. So here, carbon dioxide is in our blood. It forms the HCO3 minus, and we've got a carbonic acid in our blood. So this is a buffer. So if we add more acid to the buffer, then this conjugate base here will neutralize some of that base. If we add base, then this acid will neutralize that base as well. So your blood is a good buffer in your body. Another one would be if I was to take a significant amount of your acetic acid and mix that with sodium acetate. The acetate ion is the conjugate base of the weak acid, acetic acid. So if I have this mixture of acetic acid with sodium acetate, then what happens when I add some base? If I add a strong base like NaOH, what's going to happen is in this mixture I have sodium acetate, I have the acetate ion, and I have the acetic acid here. The acetic acid in the buffer is going to react and neutralize the sodium hydroxide, and that's going to form water and your sodium acetate, which I already have in the solution. So I'm just making more of the conjugate base, and so I'm going to lose some of the acid when it's neutralizing that. So the buffer is going to be safe as long as the amount of acid I have is greater than the amount of base that I'm adding. So then the buffer will keep the pH relatively the same. What if I add HCl, a strong acid, to this buffer? Then in this case, the HCl will react with the sodium acetate in the buffer. So the acetate ion will pick up the hydrogen. So here we have sodium acetate. So the acetate ion will pick up the hydrogen and we'll make some acetate. So I'm going to create more of the weak acid in my solution that I already have weak acid in there, I'm going to lose some of the acetate ion at the same time. And now I'm going to produce sodium chloride salt, which is a neutral salt. So here, in this case, I'm losing some of the base and I'm gaining some more of the acid. But as long as the strong acid that I'm adding to my buffer is less than the amount of the conjugate base I have in the buffer, then my buffer will neutralize the acid and it will keep the pH relatively constant. And so that's really how a buffer works. So there are a few things to remember from this video. Buffers are solutions that resist pH change. And how do they resist pH change? Because they're either made of significant amounts of a weak acid and its conjugate base, or significant amounts of a weak base and its conjugate acid. So when you put in your base, the acid in the acid in the buffer will neutralize the base, and if you add in an acid, the conjugate base or the acid, the base or the conjugate base in the buffer will neutralize the acid and therefore keep the pH consistent. I hope this was a helpful video. If you enjoyed this video and you learned something from this video, please hit the like button. Also, don't forget to subscribe to my channel. Hit that notification bell so you can be notified by other videos I put out. Put a comment in the comment section. Let me know what you think. And if you got any questions. Thanks for joining me. Have a great day.